Okay guys, welcome to this revision video looking at gradients of straight lines. Okay, so this is a perfect revision video for your paper 2s and paper 3s for GCSE Maths, AQA, EDEXCEL, OCR and any other appropriate international exam board, okay, such as the IGCSE, the CIE and the WJEC. Okay, as ever guys, please do go ahead actually and click pause, press pause and then have a go at the questions and then press play when you're ready. Okay, this is question number 1 guys. The line L is drawn on the grid below. Find the gradient of line L. Well, the gradient is the change in y divided by the change in x. So let's just start here. Okay, I go across 1 and then I go up 3. So it's going up 3 and across 1. So the gradient is the change in y divided by the change in x. 3 divided by 1 is just 3. So we represent the gradient by the letter m. Okay, because remember that straight line equations are in the form y equals mx plus c, where m is your gradient, so how steep the line is, okay, and c is your y-intercept. This is question number 2, guys. The line L is drawn on the grid below. Find the gradient of the line. Well, again, going across 1 and then up 2, yeah? So it's 2 there and then it's 1 there. Again, change in y over change in x, or rise over run. 2 divided by the 1 is equal to 2, guys, okay? So the gradient is equal to 2, guys. Okay, this is question number 3. The line L is drawn on the grid below. Find out the gradient of line L. So we're going to be a bit careful here, guys. So we go across 1 and then we go up 4. Okay, so we got 4 there, and then we got 1 there. Again, the gradient is the change in y over the change in x. Okay, delta x over delta y. 4 divided by 1 is equal to 4, guys. So the gradient is equal to 4. This is question number 4, guys. The line L is drawn on the grid below. Find the gradient of the line. So we go this time, so it's going left 1, so it's going to be like a minus 1, okay, because I'm going to the left, and then I'm going up 3, okay. So here I'm going to be very, very, very careful. So it's 3 divided by negative 1, okay, because if it's in this direction, okay, then it's a negative gradient. If it's in this direction, it's a positive gradient, okay? So that's how I know that my answer has to be negative, because it's in this direction, okay? It's going a downward slope. 3 divided by negative 1 is equal to negative 3. Okay, or the other way could have been that I go down 3 and then across 1, okay, so it would be minus 3 divided by 1. Again, it would still give you the same answer, provided that one of the signs is negative and the other one is positive, okay, for that question. This is question number 5, guys. The line L is drawn on the grid below. Find the gradient of line L. So we go across 1 and then up 1, so it's going to be 1 divided by, or minus 1 divided by 1, or 1 divided by minus 1. Okay, and I get negative 1, guys. So the gradient is equal to negative 1. Okay, so gradient, guys, is delta y over delta x. It's the change in y divided by the change in x. Okay, this is question number 6, guys. The line L is drawn on the grid below. Find the gradient of the line. So again, I go across, okay, 2 and then up 1. So I go across 2 and then up 1. The gradient this time is the change in y, which is 1, divided by the change in x, which is equal to 2. So m is equal to a half, yeah, or 1/2, or 0.5, okay. So either answer is appropriate, but if it was me in the exam, I would try and leave my answer as a fraction, because obviously some fractions are a bit more awkward, such as 1/3 or 1/6 or 1/9, okay, etc, etc, okay. But if it is, like, of course, yeah, if it's a half or a quarter or an eighth or a 16th, that's also fine, okay. But I just like to prefer to write here as a fraction, guys, okay. So m is equal to a half. This is question number 7, guys, so it's going to start getting a bit, ramp up now a bit. Okay, find the gradient of the line that passes through these 2 points. So it's the change in y divided by the change in x. So m is equal to 10, take away 1, which is 9, divided by 5, take away 2, which is 3. So m equals 9 divided by 3, which is 3. Okay, so the gradient that passes through these 2 sets of coordinates, or these 2 sets of points, is 3. It's the difference in the y coordinate divided by the difference in the x coordinate if it's not drawn visually. Okay, so if it's 2 sets of coordinates, okay, it's y2 minus y1 divided by x2 minus x1. Okay, so second y coordinate subtract the first y coordinate divided by the second x coordinate minus the first x coordinate. So question number 8, guys, find the gradient of the line that passes through 5, 4 and 7, 0. 0 take away 4 is negative 4. Okay, so being very careful here. 7 take away 5 is 2. Negative 4 divided by 2 is negative 2, guys. So it's minus 2. This is question number 9. Find the gradient of the line that passes through minus 3, 4 and 5, 8. So again, it's the change in y over the change in x. 8 take away 4 is 4. And then 5 take away negative 3. So it's 5 plus 3, which is going to be 8. So 4/8 or a half, guys. Okay, either way is going to be fine. Okay, so the gradient of question 9 is a half. Okay, this is question number 10, guys. Find the gradient of the line that passes through these 2 sets of points. 10 take away 7 is 3. 1 take away 3 is negative 2. So the answer is just minus 3 halves. This is question number 11. Again, finding the gradients passing through 1 minus 1 minus 3 minus 9. So it's negative 9 subtract negative 1. So it's negative 9 plus negative 1, which becomes negative 8. Okay, because the 2 minus signs change to a positive. Minus 3 subtract 1 is negative 4. So minus 8 divided by negative 4 is equal to 2. Okay, so please be very careful and be very wary with your signs that a negative divided by a negative, I get a positive. Okay, and that if you're subtracting and that I have 2 negative signs in between each number, then it turns it into a positive. Okay, for the sum. Okay, this is question number 12. Again, working out the gradient. Negative 3 minus 1. So negative 3 subtract 1 is negative 4. 3 minus 8 goes to minus 5. So minus 4 over minus 5, which is equal to 4/5, guys. Okay, so hopefully it's making sense so far. This is question number 13. Find the gradient that passes through these 2 sets of points. 9 take away negative 1 is 10. Okay, minus 2 minus 3 is minus 5. 10 divided by minus 5 is equal to negative 2, guys. Okay, this is question number 14. Find the gradient of the line that passes through, okay, these 2 sets of points. 10 take away negative 2 is 12. So 10 subtract negative 2, okay, is 10 plus 2, which is 12. Negative 3 subtract negative 1 becomes negative 2, okay, because it's negative 3 plus 1. If I'm subtracting minus 1, okay, I'm adding 1 essentially. 12 divided by minus 2 is minus 6, guys. Okay, this is question number 15. Okay, find the gradient that passes through these 2 sets of points. So 7 take away 4 is 3. Minus 5 take away minus 3 is minus 5 plus 3, which is negative 2. So the answer is 3 over minus 2 or minus 3 halves, okay, or minus 1.5 or minus 1.5, okay. Either of those answers are applicable and appropriate. This is question number 16, so this one's slightly more trickier. The line AB passes through the points minus 2, 2 minus 1, and 6k. The gradient of AB is equal to 5. Find the value of k. Well, following the same idea, I'm going to have k take away negative 1. So it's going to be k plus 1, okay, divided by 6 subtract 2, which is 4. That has to equal 5, okay, because that's the definition for the gradient, okay, the change in y over the change in x. It's the difference in the y coordinate divided by the difference in the x coordinate equals the gradient, okay. Rearranging this equation, timesing up both sides by 4, I get k plus 1 is equal to 20. 5 times 4 is 20. Subtract the 1 on both sides, I get that k is equal to 19, guys. Okay, this is question number 17. The line AB passes through the points minus 3, 4, and k12. The gradient of the line is 4. Find the value of k. So this time it's going to be 12 subtract 4 divided by k take away minus 3. Okay, or k take away negative 3, which becomes k plus 3. That has to equal to 4. Okay, again, I've got a linear equation here. So 12 take away 4 is 8. So let's just change that to 8 now. Okay, oops, we've still got a fraction there. Sorry, guys. So 8 over k plus 3 is equal to 4. Timesing both sides by k plus 3, I'm going to get 8 is equal to 4 lots of k plus 3, which is 4k plus 12. Okay. So I know I'm actually like jumping some steps here. So obviously it's 4 lots of this. So you would expand 4 brackets k plus 3. Okay. So I get 4k plus 12. Subtract 12 on both sides and then divide by 4. Okay, 8 take away 12 is negative 4. Negative 4 divided by 4 is negative 1. So k is equal to negative 1, guys. Okay, I do appreciate that I have actually like jumped a bit here and I'm going quite fast actually and quite swiftly. But please feel free to obviously pause it and go back here and rewatch it and rewind if you need to. Okay, remember that the gradient, okay, just to be very clear, is the change in the y coordinate divided by the change in the x coordinates. Okay, so here, question 16, 17, 18, I'm forming some linear equations, whether it's 1, 2, or 3-step equations, okay, and solving for k, essentially. So that is what I'm doing. Okay, based on the definition of a gradient of a line. Okay, AB passes through the point minus 2k, and 8, 4, 8. The gradient of AB is equal to negative 2. Find the value of k. Well, it becomes 8 take away k divided by 4 take away minus 2, which becomes 6. That has to equal to negative 2. Timesing up both sides by 6, I get a subtract k is equal to negative 12. Okay, so 8 minus k is equal to negative 12. If I add k to both sides and then I add 12 to both sides, 8 plus 12 is 20. So 20 is equal to k, or k is equal to 20. Okay, either way, it's fine, guys. Okay, so that's how to work it out. Okay, so sometimes it may give you that. Okay, it's still the same idea as question 7 to 15, except this time you are essentially working backwards. Okay, so you are given a gradient, but you're essentially rearranging and working out one coordinate. Okay, by forming, okay, and solving a linear equation. Okay, so forming and solving a 1, 2, or 3-step equation. Okay, remembering that you balance your equations respectively, so whatever I do to one side, I must do the same to the other side, okay, when I'm solving a linear equation. Okay, right guys, that's the end of today's short, sharp video. I hope you found it useful. If you did, please press like, please subscribe to the channel if you're new, and lastly, please click that bell icon so you don't miss out on further videos and further uploads. But that's it for me today, guys. Thanks for watching. Good luck in your paper 2, guys, and I'll see you for the next one. Okay, bye for now.